Okay, we are live, so
Okay, I can start.
yes.
Okay, hi guys. So I'm gonna present about Ezekiel. So zkVerify has not finished the integration yet. So if you're hacking on it, it's gonna be for the Horizon bounties. Um, so the TLDR for Ezekiel is just like a different way of thinking about ZK circuits. So normally if you write ZK, you have to write in circom noir. You have to think in terms of like the circuit itself, and it's kind of like confusing to think about. So we offer a different way where you can use something like PyTorch or even like TensorFlow to write a ZK circuit. So the idea is that you kind of want to create a flow where you can reason about problems in data science, and then have it be converted into a zero knowledge proof circuit. Because ultimately it's the same math, you just need to express it in a different form, and now it's usable in a different context. And once you have that, you can produce like a zero knowledge proof really easily without much effort, like thinking about the constraints and stuff that's handled in the library itself. So we essentially built a compiler for ZK, which uses Onyx. So I'm gonna talk about how I'm thinking about ZK and AI these days. So people have been talking about ZK ML, but I think it's really a kind of meta gaming. So like the concept of verifiable games. So if you know like ZK, it's actually really a game between a prover and a verifier. So it's kind of games upon games, right? And so if you think about what a game is, it's really a voluntary attempt to overcome unnecessary obstacles. So if you really think about a lot of things in life, it's really just a game. So existence is the ultimate meta game. Like you don't need to be here. You guys chose to be here, and now you're gonna play a game. And so if you think about what games really are, you have objectives, you have constraints, and you have rules, and also maybe adversaries that you want to defend yourself against. And so if you think about a lot of things, they kind of fall under this kind of general framework. And so you can really think of games as the optimization problem, right? So once you can turn it in this form, like, tada, that's where you can use AI. This thing. And so the idea here with this, like, I think this concept is how can you view the world as a game? And then how can you view its various like functions? So like everything is like a function. Like you go and eat is like a function. You turn food into shit, and then it becomes energy for you to do things. But once you can get it into this mathematical form, it means you can now prove it. But then the question is, why would you want to prove it? And hence, we are gonna fuck around and find out. um, right. So I'm gonna talk about the kind of experiments that we have done in like the past 1 year or so. So there's like BitTensor, and there's also DeFi stuff with like a recent hack that I did called CockSwap. It stands for cleverly optimized and computed swaps. CockSwap. And also like internet arcades. So BitTensor, I think, was like this is still running. So we are working with Omron for quite a while. So the idea is to kind of verify like the reward the reward values on BitTensor. So it's still live right now, and essentially like Ezekiel and Circom is used to calculate like how much rewards you should be given per block on BitTensor. So for some context, BitTensor is basically like it's like Polkadot plus AI. So they have like a main chain, and you kind of have subnets on BitTensor, which are kind of like parachains, but for certain like AI tasks. So here's like the story behind me and BitTensor. So I thought that BitTensor was a scam. So it sounds very salty to me because so there are a few problems I have with like decentralized inference per se. Like, do you really need consensus on generative AI? Like, if you generate once like a funny image, like, do you need to have consensus on the funny image and you generated? Like, what value do you get out of it? And can you actually decentralize AI? Like you kind of need very powerful GPUs, powerful compute, and the more powerful compute requirements you have, the harder it is to decentralize. And once you have like larger models, like they tend to hallucinate. Like most LLMs have like adversarial samples. So what can you actually do about it? And also the next other thing, I think there are a lot of like GPU networks. And so historically, things like Golem has kind of fizzled out. So just having a utility token plus GPU introduces unnecessary complexity. So if you're a company trying to get GPUs, maybe like paying the token is cheaper for now, but you have a variable expense for your company now versus paying like a cloud hosting provider like Vast AI, for example. So yeah, those are some kind of issues with decentralized inference. But there are a couple of interesting things that happen with BitTensor. So I think like what BitTensor is actually a kind of on-chain game in this case. So you have a lot of miners who kind of register on BitTensor and that goes to like generate inference and proofs as fast as possible. So there's not like a market for making faster AI systems. And so that was like kind of it. Like this is I did not actually foresee this happening. And so it's not like a game to build like the better and faster AI inference system. And this actually helped like EZKL become quite fast. So we found actually optimizations for it. And some people were able to like bring the proof times down. And so that's actually one of like the main reasons why like I think EZKL is way much faster. It's actually also partially due to BitTensor. Um, and also what's interesting is that maybe you don't really need large inferences. So you can kind of prove smaller models. And so they are more understandable mathematical functions. And so that's how we are thinking about like zkML or AI stuff per se. Not very large model, like smaller models which with an understandable like function space. Then the next other thing which was interesting was this thing called CockSwap. So it really came up from a hack that I had in Hackerhouse this year. But the idea about thinking of DeFi and ZK and AI and stuff is that you can kind of think of DeFi as optimization at resource games. Like how can you allocate your resource in such a way that you're able to get the most yield? So if you think of DeFi is basically like the first on-chain game. I wouldn't say first, but more like the first few on-chain games. So you don't really need like a MMORPG character, you just need numbers to go up. But this is like the key idea behind like CockSwap, right? So this part of it is live right now, but the idea is to have a master pool. So I think you're gonna see this happen like more often. I think a lot of projects are starting to converge onto this design. So the idea is that you have an on-chain pool that does AMMs, also does lending and borrowing and all in one. And so the one issue with this is that the more complexity you have, the more foot guns you have. Like you can strip yourself or like lose funds. And this is where verifiable AI kind of helps, right? You want to know whether the decision space or the modifications you're making to a pool makes sense. So this is like the idea. So this was initially built on Balancer V3, and so part of it is live. So Balancer V3 offers a very interesting code. So that's like Aave boosted pool. So because like not all the tokens are traded all at once, you have some leftover tokens that can be put on Aave. And so you can actually earn yield on some like the leftover ETH tokens. So for example, I have ETH USDC, I can actually put a chunk of it in Aave and allow ETH USDC to still be swapped on the main pool itself. And then within the pool itself, you also have like few more parameters. Like how do you verify the optimal pool weights? So I'm having like ETH USDC, like do I really want to have 50-50? So if like ETH is going up, maybe I want it to be like 80-20 or something. And so you can also introduce like portfolio rebalancing algorithms here. And the next other thing is that you can also introduce dynamic fees. So dynamic fees I think it's like a lower risk one. So this is dynamic fees are actually live right now, and we are iterating on a bunch of designs. So we have like a bunch of quant strategies which are actually more profitable than static fees. And ZK is interesting because once you have a strategy that works, you kind of don't want everyone to know about it. And so that's where ZK is actually kind of handy.
I have a question.
Yes.
So over here, if I understand the workflow properly, that you have a pool out there, and to balance it, you can have like some kind of quant strategies which are like mostly into ML or AI,
Yeah.
and then you feed it to EZKL to basically verify the inference on chain,
Yeah.
and then based on that, you basically optimize the pool for that.
Something like that. So the idea is that you can essentially just change the pool weights, right? And then it will give an arbitrage strategy. So you can sort of interpolate with like the pool weight. So you don't want to change it too much and then cause a huge massive slippage for LPs. So you can gradually adjust to like the intended portfolio allocation percentage.
Okay, and like when you're using the quant strategies or the ML strategies for this, and like I assume like there will be kind of at least some kind of complex models to say.
Not really. It's actually quite simple. So, but that's the catch. So finding the simple and effective model is difficult. You can try it yourself, but yeah, and so that's where it becomes like a bunch of proprietary strategies.
And what's the proving time for those things?
So for the larger computational models, like probably about a minute.
Okay.
So which is like decent. So the reason why it became like slightly more because we end up using a lot of exponential functions. And so because of the exponents, you have to kind of do a larger lookup operations. Yeah, it's just like the downside. So one of the other things which I'm thinking of is to introduce some kind of numerical approximations. So if you've done like a lot of quant strategies, there's this thing called sigma functions. Like it's like log or exponent to the exponent or something, which introduces like a bunch of complexities when you compare to the ZK circuits because the arithmetization does not handle like exponents well, but it's somehow used a lot in like quantitative modeling. So that's like one, I guess that's one like possible model to think about. Yeah, but that's essentially one of like the approach like of like using like ZK. And so this is kind of like I think like the major push that we are thinking of right now. And the next other thing that we are also thinking of in greater detail is like how can you introduce real world assets to this. So the other thing that is important for verification is also an RWA. So think of like treasuries and stuff. You want to put it on chain. You kind of also want to verify like the assets. So how can you have like a computationally sound audit on chain? And that's where something like ZK actually helps. Because like right now, if you think about things like USDC, USDT, you have human auditors who come into the system, writing a paper audit, publishing, and then afterwards letting people view like a paper audit. But this paper audit has no correspondence on chain. If something happens to like the company, all you can do is just sell your USDC, and there's like no guarantees on like the underlying collateral. So if you can build a system that has like a correspondence like to some kind of offline treasury system or treasury management, and have some kind of like correspondence on chain like that, I think it's really powerful. And yeah, I guess that's like easing regulations on the US side of things. And so I do think like one of the killer applications in ZK will be around this RWA management systems. So there's probably, I think, at least like a couple of unicorns that can be built in this space. So just food for thought. Yeah, my execution is always like hard. And so that's the next idea, which this is slightly more fun. I kind of enjoy working on this more than the other stuff. So the other ones make money. This is like it's just for fun. So like so I'm not sure whether you guys heard of autonomous worlds that you were hearing about for a while, but I kind of fizzled out, right? Because I think the games were not that fun. Yeah, but I think like the gaming thesis is not dead. Just for having pure entertainment. So I kind of don't want to think of it as autonomous roles. Like I think people think of two grand visions. Like people, if you watch like Fortnite, people just want to have fun, or like people in Minecraft, they don't really give a shit about or like how much money you're gonna make. People just like trying to do something stupid and have fun. So one of the first applications we built was on-chain karaoke. So it's called Crypto Idol. And so I think like two interesting applications that can be done here is like maybe some kind of online scoreboard and also maybe cheat detection. So verifiable karaoke is fun. I can't do a demo right now, so I think this should be live. It will take a while to verify. So it looks like this. So it's like a sync to min. So I can connect
Sorry, Jseam, share the screen on the yeah, so we can see it.
Oh, sorry.
On the karaoke, no, sorry, on the karaoke tab.
Yeah,
Just
you
share
have,
the screen at the top.
On the upper side, you have share this tab instead. You just click that one. Go to the another tab.
Yeah.
Yeah.
Click on that. And at the top.
Share this
Share
tab.
this tab instead.
Okay, sure. This tab is it.
Mhm.
Okay. Are we able to see this?
Yes.
So this is really cute. I made this application. So this was actually a way for us to test like the end-to-end flow of how.
You want to know your password now?
Yeah, that's good. This is my test account.
Everyone says that.
Yeah, this is actually my test account. Yeah, so basically what you can do is you can sing to this. Hello, 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 hello. Blah, 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 blah. Hello. Okay. Yeah, and so basically you will submit the proof stuff and you'll build it will basically give you a score for your voice. This takes about a while, so I think we can let it wait. But once you are done, like it means you're NFT. So this is how it looks like. I can share this with you.
No, I want to see the value of your skills here.
I'll show you afterwards. So I also did this NFT collection. So it's like yeah, all the SVGs are actually on chain. So the whole artwork is actually stocked on chain. So I was like manually computing the SVG values. Yeah, and so this project is called Crypto Idol. It's like quite cute. Yeah, this was done on like an older model for EZKL, so it takes about a minute. So the model here is quite a large model. I think about probably around like 100,000 parameters.
Oh.
So it uses I think I use depthwise convolution for this. So maybe I'll talk more about how like the model actually works. So this is I think like an older test model.
What is the result?
It will take a while. Yeah, but I'll go into detail on how you can actually run a voice verifier. So this might be interesting to think about because I don't think if you're writing like in Noir or Circom, like this would actually be possible. So the reason why we chose like voice, it was like it's like one of like the examples which might not be very feasible in Circom or Noir, but it could be feasible in this flow. So we basically took a bunch of like voice data sets online, combined the data sets, and then afterwards train on those. And so in this case, we are essentially classifying the tone of your voice. And this is like the model that we use. This is like the simpler one. So it's used in our test case. And so you can essentially run, I'm not sure how familiar you guys are with ML training, but there are examples there in PyTorch on how you can train a model. So once you get like, so in this case, you're just doing classification. So you're just essentially optimizing across the entropy loss. Let me know if this like ML stuff is like no one is familiar. So please feel free to stop me. Yeah. So once you train this, you basically have an Onyx file for like the network with all the train weights. And so this is where EZKL comes in really handy. So you can generate like some random value, export it out via Onyx like this. And once you export it out with Onyx, you can essentially convert that to a JSON array.
There's a question here.
Yeah.
Can you please explain that Onyx function? What does that Onyx function do?
So Onyx is like a file exchange format. So I think it stands for Open Network. I think Open Network Exchange or something.
Yeah.
So it's just like an interface that is like used in most systems. And so it's you can think of it like as a specialized language for AI models.
Okay. So we can think of it like we can exchange from one form to another. Is it like that?
Yeah, so it's just like a universal format for most AI libraries.
Okay.
Yeah, and so we use that same format and then use that as a kind of like a intermediate language that we can convert to a ZK circuit in Halo 2. So we use that and then plop it into Halo 2, and then you can create a circuit out of it. And so once you have that, essentially like the library that we built does all the heavy lifting. So you can run generate settings and then calibrate settings to essentially find like the most optimal values. And this is where the magic happens. Like you can literally just call compile circuit and it basically figures out the whole circuit for you. You don't need to write it in circom. And once that is done, you just need to get like the SRS because you're using KZG. Like so you need like a structured reference string. And you can just like literally worry about this.
Just share the status. Yeah, thank you. Okay, you're good.
Yeah, so you can basically then run setup. And once you get set up, you'll get two files, like the proving key and the verification key. And you will be able to generate a proof just like this, which is pretty damn handy. And then you can verify this, and that's basically like the key flow. And then we offer like another helper function called create EVM verifier, which uses like the same verification key and converts it in solidity. And you can just deploy the solidity verifier and it will work on chain. Oh, okay, I got a C. Okay, so my result is live right now. So I got a C. So I can actually commit my results here just like this. See? Why I'm getting an alert? Oh, I don't have enough E.
It may be network also like maybe there are more traffic. You can refresh the page.
Yeah, I might not have enough E. That's fine. Okay, so but once you commit the results, like so you do a commit reveal mechanic. So you commit the results, and then you can reveal your NFT after a bit, and then you'll get like this one of these NFTs over here. So yeah,
It's basically like NFT platform. Like you after you commit the results, and NFT gets generated. Is it like that?
yeah. So the NFT that generated is dependent on the time and the score.
Okay.
And so you get one of these NFTs, and they evolve with time. So the traits change every single block.
So like that NFT, you have integrated AI for generating NFT.
Oh no, the end like this artwork is done by me. I draw out of Figma. So the artwork was generated. I'm the AI.
Okay, got it.
Yeah, you can check like the contract itself. So I wrote it in SVG in Figma, exported the SVG out, put it in Solidity within like the token URI, and it gives you this.
Okay.
Yeah, so this is like one of the fun experiments that I did. Then the next one is also kind of interesting.
Jseam, we have a workshop in less than 2 minutes.
Okay, I'll just quickly run through this. So the other one, which is also kind of handy, is like autoencoder flow. Sorry, do I?
No, go on. Don't worry. Yeah. It's all you. It's all you.
Oh, okay, so
Take it and notice.
Okay, I think this is also like a very interesting idea. So I think I did mention yesterday about like the anomaly detection stuff very briefly. So I'll share more about this though. So I'm not sure whether you guys tried verifying zkVerify. So in this case, we are essentially trying to use anomaly detection to then classify like good or bad games. So instead of like encoding the rules of the game within a circuit, what you might want to encode is like statistically improbable events. So this is we can just for tic-tac-toe, the state space is quite small. We can generate all the good and bad games. And so in this case, we're using this technique called an autoencoder. So it's like a kind of anomaly detection technique. And so this is how it will work. So once you actually train the autoencoder, it will more or less learn a latent space of what a good or bad game looks like. And you're then able to get like the range. So you can get a quantifier value for what like normal data looks like. So I guess like they removed the images. But for example, like this would give you like a scalar value for a score. So for example, if the latent space, if you take like the mean square error or mean absolute error, if it gives you like a certain score, you'll see that normal games are clustered in one location, and bad games are clustered in some other location. So if you're greater than this amount of value, it means like you have likely cheated or like something weird has happened, and then you should basically mark those games as wrong. So I think this is like really powerful, right? Because I think one issue with a lot of like the ZK-based kind of games, they are very restrictive. You can't do really crazy stuff. So with a technique like this, you have two upsides. You don't need to encode the rules of the game within the ZK circuit. You just need to understand the statistical representation of the game, prove it if it is ZK, and then you're able to also then verify any kind of games. I have not tried this with CSGO, but I actually wanted to. I did not have time to create a verifiable CSGO game. So this would be very interesting, right? So instead of having like moderators, you could very well have an online betting platform for esports and have like a ZK verifiable CSGO game, and you can have people like vote on it. I think even for CSGO, there's no good cheat detection for this, and so there's like one other possible approach of detecting bad games. And so EZKL basically also just makes it really simple. So we built a lot of like tooling for this. You just export the Onyx and then do the exact same thing, like generate settings, calibrate settings, and run the setup, and ta-da! Now you have a verifiable system for this. Yeah, I will basically like stop here. This is just like some of like the hackathon things that I have done. So I also regularly hack on my own stacks. So yeah, I'm kind of like actually. Oh yeah, so proof of retard. This is actually not done using EZKL, but I thought it was cute. So it just uses ECPSA signatures. So this is another hackathon project that I did. It's just like a joke. So you want to see like some of the questions? It's quite wild. Yeah, so you can start the retard test. So are you left curve enough to survive in crypto? So this is generated by LM. We're not going to prove like the yeah, we're not proving like the AI per se. We're just like evaluating your score. Oh no, I think Claude is not working.
Yeah, I think Claude is banned here.
Wait, it's Claude banned in Vietnam?
Yeah, I'm not able to use it through the API.
I think it's not. Okay, never
Have you
mind.
tried it with the mobile internet or the
Wi-Fi.
Try it with the mobile.
I guess Claude might be banned. But yeah, if you want to try it, like the roles were quite funny. You see, like the API is overloaded because it's as slow as you are. Please try again. Okay. Okay, I don't think this is happening. Yeah, but that's mostly it. So if you have any questions, handle Jseam, Alex, and Telegram, and JS at EZKL So you can feel free to just send me a message, and you guys who are here, you can also just ask me directly. Yeah, so those are just some interesting ideas you can try out. And if you want to hack this some other time, I'm happy to help you guys with any questions. Any questions? Or that's all.
You're good for now.
Okay, amazing. Okay, let's move on to Brevis.
Yeah, Beverage might not be today.
Oh, wait.
Yeah, so you actually still have time if you like to.
Yeah, that's it on my end. Wait, why the proof of retard is not generated?
You can try mobile later.
It's too much retarded.
Yeah, it's still retarded. No, it's still retarded.